Alrighty, as we go through and solve example D, we first recognize and notice that we have two square roots. Now, we would like to combine them if possible, but they are not going to be like terms, so I won't actually be able to do so. Remember, you can only have radical something minus radical something and be able to combine them if what's under the square root or cubed root or whatever is the exact same. So, in order to solve this one, we are going to start by squaring both sides, which will get rid of the square root on the left, which is good. So I have x plus 6. On the right, we are going to have to FOIL. So our first term is that square root of 11 minus x, and our last term is 3. And so instead of squaring it, we can also think about as multiplying by itself. So I multiply my firsts. Square root of that times itself is just going to be that, but without the radical. So 11 minus x. My outsides, I'll have negative 3 times the square root of 11 minus x. So minus 3 times. And then notice that your insides are the same. So minus 3 radical 11 minus x again. And your last's minus 3 plus 9. Notice that these two terms in the middle are going to combine because they are like terms. And as I'm doing that, so minus 6 radical 11 minus x, I've got a couple other like terms I can combine. So I've got this 9 and this 11, and so I've got 20. That minus x is along for the ride, and then x plus 6. Now I'll start to isolate this square root because I can still go ahead and rearrange and solve for that. So the hard part is actually behind us, which is good. So now we're going to isolate that radical. And we'll do it by adding this x. So then I've got 2x, and then subtracting this 20. So minus 14 equals negative 6 radical 11 minus x. And then I need to get rid of that negative 6, so I'll do it by division. And notice I have all even numbers, so I'm going to reduce everything by a factor of 2. So I'll have 1x, negative 7 over negative 3. So then I have x minus 7 over negative 3 equals the square root of 11 minus x. Now I can square both sides to get rid of that square root. When you do, we get a FOIL again. So we have x minus 7, and it's going to be squared, right? Because when we distribute that, you can't distribute it to the x and then to the 7, because x minus 7 is a binomial, and so you have to square it. So your numerator is going to become x squared minus 7x minus 7x minus 14x plus 49 all over negative 3 quantity squared is going to be a positive 9 equals regular 11 minus x. And then I would say we've got a couple different options, but you want to know something? I don't like that 9 in the denominator, so let's just multiply both sides by it and be rid of it. So it's gone there. I have x squared minus 14x plus 49 equals 99 minus 9x. Well, now from here, I'm able to solve like I normally solve quadratics. So I want 0 on one side, so I add 9x, so x squared, and then minus 5x, and then I would subtract that 99, so I have minus 50 equals 0. Believe it or not, this is actually factorable. So from here, I would look at that and say, oh, I have x and x. I need two numbers that multiply to give me 50, subtract to give me 5. My signs are different. My bigger one's minus, so I have minus 10 and plus 5 equals 0. So I get positive 10 and negative 5. Great. However, we have to plug them back in to make sure we don't have any extraneous solutions. Remember, we like to plug them in at the very beginning, so I'm going to get rid of that mess so we can actually see the equation. So plugging in positive 10, I would have square root of positive 16 is equal to, question mark, square root of 11 minus 10 is 1 minus 3. Radical 16 is 4 equals 1 minus 3, negative 2. That's not it. So that must mean that 10 is extraneous. We have to test both of them because sometimes one works, sometimes both work, sometimes neither work. So plugging in negative 5, I have the square root of negative 5 plus 6 gives me a positive 1 equals 11 minus negative 5, 16 minus 3. 1 equals 4 minus 3 question mark? Yep. So that means that my solution for x is just -5.